encoder is an electromechanical device that provides feedback information in a closed-loop motion control system. This information is for both rotary and linear mechanisms. Optical encoders provide information for direction, position, and velocity. Direction, position, and velocity. Let's adjust the velocity of this motor. You can see how adjusting the velocity of the motor affects the velocity of the conveyor belt. An optical encoder typically has four major elements: light source, light sensor, optical disc, and signal conditioning circuitry. The light source is typically a light-emitting diode, or LED. Instead of producing a light that is visible to humans, an infrared light is usually transmitted. The light sensor is a phototransistor. Because the sensor is sensitive to infrared energy emitted by the light source, ambient light has a minimal effect on the sensor. Optical disc. A disc is placed between the light source and the sensor. It is connected to the shaft being measured so that the disc and shaft can rotate together. As the disc is rotated, light alternately passes through the translucent slots and is blocked by the opaque areas between the slots. The phototransistor is connected to the signal conditioning circuitry. The signal conditioning circuitry consists of a load resistor and the Schmitt trigger. Let's see how the circuitry works as the light is alternately blocked and passed to the transistor.
Encoder is a device that converts linear or rotary movement into digital or pulse signals. The most common type of feedback device is the absolute optical encoder. An absolute encoder consists of the four major components: a rotating encoder disc, a light source such as an LED, a photodetector as the light sensor, and a signal conditioner that converts the signals into square waveform. The encoder disc consists of a series of opaque and transparent tracks mounted to a rotating shaft. The tracks of the disc are arranged concentrically around the center of the shaft. Photodetectors assigned to each track designate the resolution of the encoder. The higher the number of concentric tracks, the higher the accuracy. A light source located on the opposite side of the photocells passes light through a capture plate. As the encoder disc rotates, light is either transmitted or blocked according to the pattern. The received light provides a 4-bit word that indicates position of the actuator or device the encoder is mounted to. The most common types of numerical encoding are decimal, binary, and gray code. In a 4-bit encoder, there are 16 unique combinations or numeric code every 22.5 degrees. Gray code is designed where only one bit changes at a time, contrary to a binary system where one or more numbers change in the word. By changing more than one number of the word at a time in the binary system, the possibility of positioning errors is greater, leaving gray code the preference in precision applications.